What is that popping in your ear when you are on an aeroplane?
This is due to drastic change in air pressure. As we know, the air in the atmosphere is made up of what? That's right, a number of gases. These gases press down on the Earth's surface, exerting a force that we call atmospheric pressure or air pressure. Although we are usually unaware of this, it is actually pressing down very hard, roughly equivalent to the force of an elephant balancing on a desk.
Jenny, why don't we implode? Because our fluid pressure inside of our body counteracts with the atmospheric pressure outside.
Pressure exerts a force on an object. The formula for pressure is force by area. Force is a push or pull on something. As explained in Newton's second law of motion, force is equal to mass by acceleration. So pressure is basically mass times acceleration over area. Pressure mainly depends on the altitude. If we travel up a mountain or go up in a hot air balloon, for example, the air pressure gets less the higher we go, until there's no oxygen and our eyeballs will pop out. We can explain this difference by comparing air pressure to a pile of blankets on our bed. Air pressure at sea level is the equivalent of having many blankets, which would feel very heavy. If you have only one blanket though, it would feel very light, and that is the case at the top of the mountain. Each layer of air pressure presses down on the layers below, and the greatest pressure is at the ground level where we have the maximum air pressure. At ground level, the air is tightly packed and the intermolecular spaces between the air molecules are less. Whereas if we go up the height of the mountains, the pressure will decrease until it reaches about zero, as there is hardly any air above it, and the intermolecular spaces between the air molecules are high. Changes in air pressure bring changes in the weather and make wind blow. Air usually moves from areas of high pressure to low pressure, and this produces winds.
But how do you know if there is air pressure or not?
Well, here's a simple experiment by Dr. Kyungho Shin.
Hi, today we're going to do experiment about air pressure. We need a jar about a bit bigger rim, and a napkin, matches, and a balloon.
So first you have to take a small napkin and light it with match or candle and put it in the jar. Then quickly cover the jar with the balloon on the top. So what happens is, napkin is burning and it sucks all the oxygen out of the jar, which sucks the balloon, and also air pressure is lower in the jar compared to outside, which is higher. The higher pressure pushes the balloon in and the lower pressure sucks the balloon in.
What are some real-life examples of atmospheric pressure?
When you are drinking water with a straw, you are removing the air in the straw, which allows the air pressure acting on the surface of the liquid to push the liquid up the straw. When you are inflating a balloon, the air inside the balloon will have a greater air pressure than the original atmospheric air pressure, while the inside forces cause the balloon to expand. High air pressure inside would expand based on the high amount of internal forces.
See, here's the question. How do we calculate atmospheric pressure? Well, several complex equations can be used, like this one, or maybe even this one. But all these equations are way too hard. That's why there's an easier way to do all of this. Behold the barometer. A barometer is an instrument measuring atmospheric pressure, and it is measured in millibars. If the readings are over 1010 millibars, it indicates high air pressure.
Thank you for watching our demonstration.
Thank you for listening.
We hope you enjoyed.